This is a folding version of the common Stanley knife. Thumb stud, lock back, pocket clip, not the smoothest opener, even has a choil. This is 50-50 with the Olfa knife in being the utility knife of choice locally. Insulators tend to prefer the Olfa knife, and carpenters and drywallers tend to use the Stanley knife. Not a lot of them use the folding clippets like this. A lot of them prefer the straightforward ones that you see in most hardware stores that are one piece, and very common are the ones that can store multiple blades inside of them. And this part here usually splits open and you can take blades out. Now you can get all kind of fancy blades for this now. Bimetal and high-speed steel blades are really common to improve edge retention. Along those lines, I've been carrying the cubic boron nitride rods for the Sharpmaker and using them to touch up utility knives like this one, and even saws that are used to cut mineral wool insulation. Now the feedback from them have been very positive. Most people praise the initial sharpness and no problems whatsoever with the edge retention, which surprised me a little bit because this blade is so short you don't get much of a draw or slice when you're cutting. Most of it's a push cut, and for push cuts you would expect a much higher grit finish or a polished edge to be better. So that was a bit surprising to me, but I figured that what they might actually be comparing is nothing more than using a very sharp edge versus a relatively dull one. Because if you don't actually sharpen these blades, most people use them in a dull state, because you're not going to be constantly replacing them, even though they're rather inexpensive. They only cost around 25 cents if you buy a huge big pack of them. You don't want to be constantly throwing them out. Just think about if you're cutting very hard materials, insulation, drywall, and cutting on concrete and a bunch of other things and stripping wires. These guys aren't exactly gentle with knives. You're not going to be able to keep this very sharp unless you're replacing blades tremendously frequently. So I was thinking, well, yeah, they might be comparing the edge that I'm putting on with the cubic boron nitride rods to a blunt edge. Well, anything is better than a blunt edge. That's not much praise. So I decided to do a little experiment. I had a bunch of cardboard boxes that were actually of the same type, which is rare for me. I usually get a lot of reclaimed materials, but someone was doing some flooring. So I had a few thousand square feet of leftover flooring boxes. It's a decent amount of cardboard. So I said, well, I can do then kind of interesting little experiment where I'll keep the cardboard the same. Usually I do random sampling, but you had to do much wider runs when you're doing random sampling. So since I had all the same cardboard, I could do smaller runs, and hopefully I'd have decent consistency. So I took the edge boxed edge, I just bought a pack of blades, and I cut up some 1/8 inch thick ridged cardboard along the ridges, using just only the amount of a draw as you can get with this very short blade. I measured the edge retention. And I was using the new statistic that I've been playing around with called the TCE, total cutting efficiency. And essentially it's a measure of how much cutting you can do as a function of how much work that you put into it. So the higher the number means the more cutting you can do with a given amount of work. So it's sort of, that's why I'll call it cutting efficiency. So a blade that can keep a relatively high sharpness obviously has a higher cutting efficiency, because the harder sharpness, the less work it requires to do the cutting. So I measured that for the as-box blades. Then I sharpened them on 15 degrees per side with the cubic boron nitride rods. And the initial sharpness on a slice came out to be almost identical to the as-box edge, which was kind of surprising. And the edge retention was only slightly less, but not significantly less. It's relatively difficult to get edge retention statistics that are extremely precise. A lot of people claim to be able to do foolish things, like I can cut 561 pieces of rope with one knife, but another knife only cuts 755 or some foolish made-up number. You can't get near that precision. If you just think about it, how much force you put into the cut, the amount of draw that you use, the angle of the blade to the material, all these things influence the results, and they all add up. And do you really think you can get any of them to within a small percentage? No. I mean, at best, the amount of force you're putting, the speed that you're doing the cutting with, even if you're really, really precise, these are all going to vary by about 10%, and all these percents add up. So you're not going to get anywhere near a percent or so of precision. Anyone who claims that is just making up numbers. It's very easy to make up numbers. So, with a few runs on each, and I did about a half dozen runs with each finish, the edge retention and initial sharpness was not significantly lower for cubic boron nitride rods, which matched up with the anecdotal feedback I was getting from the guys who were saying that, yeah, edge retention was great and the initial sharpness was great. I looked at the diamond rods, which look identical to these, and in fact I labeled them to make sure I could tell them apart, and it was not significantly different from the cubic boron nitride rods. I then tried the medium grit rods on the Sharpmaker, again at 15 degrees per side, and that's where I had a bit of a surprise, because the edge retention with the medium grit rods was significantly lower than the cubic boron nitride rods. That didn't make a lot of sense to me, because again, since you're doing a very short draw, a higher grit finish should be of higher performance, because the more you move towards a push cut, the more improvement you will see with a higher polish. But looking at it in a bit more detail, what happens is the first almost couple of passes that you do against the medium rods, the sharpness goes up almost back to as boxed, or almost back to 100%. Now that's where you might think, well, great, that's what you want, isn't it, to get the sharpness back almost immediately? No, because if you think about an edge, okay, so the apex should look like this, nice and sharp and completely formed. If you've ever looked at an edge under magnification that's been used, it's all dented and twisted up. There's no way that this rod is cutting off all that dented and twisted up material in just 2 passes. Which means what it's doing is just pushing all that dented and broken up material back into a sharp line. So your edge, even though that is sharp, is made out of that dented and fractured material that's weak and brittle. So the edge retention is not that great. So that's the idea anyway. So to test that, I did 2 additional experiments. Number 1, I took a smooth steel, and this is a really cute little folding steel from Razor's Edge. You can set these at any angle that you want. They come with 2 little arrows for preset angles, and then you adjust these little screw sets to keep them locked at that angle. Or you can just fold them all the way out straight and use it as you would a traditional straight steel. So I used these, and again, couple of passes and the initial sharpness was relatively high, but the edge retention with this was even worse than with the medium grit finish, which is what it should be, because this isn't going to remove almost any material at all. You'll get a small amount of material removal because of burnishing and steel on steel, but it's very, very minuscule. So the edge retention with this was significantly worse than the medium rods. So then I did another experiment to confirm the idea. So I took the blades, this primary edge bevel I flattened with a relatively coarse Waterstone. I use a Bester 700, which I've been using for almost everything for the past year, and flattened this edge bevel and brought it to a completely new clean apex. So all that dented and fractured material was all ground off. Primary grind was recut. Then I looked at the edge, then I formed the edge with the medium grit rod, then looked at the edge retention. Now, if my hypothesis was correct, the edge retention on this should not only be significantly improved over when I did it before, it should be better than the cubic boron nitride rods, and possibly even better than the as boxed edge. And it was significantly higher than everything. So, the interesting thing that came out of all of that is that number 1, the cubic boron nitride rods are kind of a little cool thing to carry around with you. They come in this little tube, so it's easy to drop in your pocket, throw in your glove compartment, and it can easily sharpen all manner of utility blades and even tools, not just knives. I was also doing some pruning shears and stuff like that. It's relatively cool, so that's useful. The other thing is that using not so optimal grit in this case cubic boron nitride rods, gave better results than using the optimal grit, or at least more optimal grit, the medium rods, if you are cutting the edge off completely in one case and leaving deformed metal. So when you're looking at sharpening, it's not just a matter of grit and angle, it's also an influence of how you're using the abrasive. So the cubic boron nitride rods were that coarse that with even just a few passes, they were cutting off all that weakened, the deformed and fractured metal. So even though the edge was a bit too coarse to be optimal from a grit perspective, it was formed on optimal steel. The medium rods, on the other hand, even though the grit was more optimal, it was forming an edge on damaged and weakened steel, so that the edge retention was significantly lower. So again, kind of an interesting little experiment to do, showing how valuable that the cubic boron nitride rods are, and in some cases they may give better edge retention than even rods which have a more superior finish, simply because of their ability to very rapidly remove all that damaged and worn material.